Section 5.9 concerns complex numbers. Complex numbers are a combination of imaginary and real. Definition of an imaginary number is a number that allows you to take the value of a negative square root. So previously, if I went to take the square root of -4, I would have an empty set or an impossible answer. But we've learned in this chapter that we can break down square roots. So the square root of -4 is equal to the square root of 4 times the square root of -1. And because the square root of -1 is I, the square root of -4 is 2I. 2 comes from the square root of 4. I comes from the square root of -1. So, like you could look at the square root of -12 as the square root of 4 times the square root of -1 times the square root of 3. The square root of 4 is 2. The square root of -1 is I. And I would have to keep the square root of 3. So the square root of -12 is 2I on the square root of 3. 27, I would have the square root of 9 times the square root of -1 times the square root of 3 times the square root of x cubed. So I have 3 comes from that, I comes from that, square root of 3 stays underneath there, and you know that I can pull out one x here and I keep an x underneath. Now typically what you'll do is you'll always put the I at the end. So 3xi on the square root of 3x. I squared is always equal to -1. You are never allowed to keep an I squared in an answer. So if you have an I squared, it always has to be changed to a -1. So if I have a -3i times an 8i, and you can more or less look at the i's as like variables. So I'm going to have a -24i squared. But like I said, I cannot keep the I squared. I have to look at the I squared as a -1. So -24 times -1 is going to give me a positive 24. Down here, I've got 8 times 5, which is 40. I times I is I squared. So my answer here would be 40 times -1, or a -40. Now over here, I've got to break these down first before I can multiply them. So this is I on the square root of 6 times I on the square root of 10, which is going to give me an I squared times the square root of 60. Now the question would be, can I break down 60? And I can divide 4 into that. So I have I squared, which is a -1 times the square root of 4 times the square root of 15. So I have 2 times the -1, which gives me a -2 on the square root of 15. Same thing down here, I times the square root of 5. And if you want to, go ahead and break this down as 4 times 5. So it's going to be a 2i on the square root of 5, because the square root of 4 is 2. So now on the outside, I have 2i squared times the square root of 25. Square root of 25 is 5. So I have 10 times -1, because that's what I squared is equal to. So it's going to give me a -10. We also, with an I, can simplify base and exponents. You're always going to write it in terms of I squared. So if I have I to the 25th, that's the same thing as I squared raised to the 12th power, because that's going to give me I to the 24th. But then I need to get to 25, so I need one more I. So this gives me I to the 24th times I to the 1st, which is going to give me I to the 25th power. So if you look at I squared as -1 anytime I have -1 raised to an even root, I'm going to lose my -1. But if I have -1 raised to an odd root, I'm going to keep my negative. So this is going to be -1 to the 12th power is 1. 1 times I is I. If I come over here, I to the 2nd power, to make it be 12, I need to raise it to the 6th power, because 2 times 6 is 12. So I have a -1 raised to the 6th power. That's an even number, which means I lose my negative, and my answer is just 1. I to the 17th is an I squared raised to the 8th power. That's going to give me 16. I would need one more I to make it 17. So I have a -1 to the 8th power times I. -1 to the 8th is 1. 1 times I is simply I. All right, you're going to use these to solve equations. So if you look, all my algebra rules stand. I'm going to add a -36 to both sides because I want to get the x by itself. So I have 4x squared is equal to -36. I'm going to divide by the 4. And when I do that, I get x squared is equal to -9. Well, to get rid of something squared, I have to take the square root. So I'm going to take the square root of both sides. I'm going to bring it up here. So I'm going to have x is equal to plus or minus the square root of 9 is 3, but it's the square root of a negative. So it would be, well, let's do it this way and you'll see. So that's going to be equal to plus or minus 3i, because remember that's -1 times 3. But you've got to put plus or minus there because you're taking the square root. This one, I'm going to subtract 81 from both sides. So I'm going to take the square root of both sides and I'm going to get plus or minus 9i. As the square root of 81 is 9, the square root of -1 is I. Coming down here, I have I squared is equal to -72. I've got to break that down when I take the square root of it because I'm going to take the square root of -72. So I know I'm going to have an I, but that's the same thing as 36 times 2. So A is equal to plus or minus 6i on the square root of 2. Because 36 times 2 is equal to 72. But notice if I have a negative underneath my square root, I'm going to have an I in my answer. All right. Then you can do just normal math with imaginary numbers. And more or less, you're just going to treat them like variables. The only time you don't treat it like a variable is if you have I squared. And if you have I squared, you always have to change it to a -1. So this is just addition. So if you looked at that as like a variable, you add the like term. So that's going to be a 10. And then I have a -5i and a positive I, which is a -4i. Okay. This one is another addition. So I'm adding the 8 and the -12. So I have a -4. I'm adding the 7i and the 11i, which is going to give me an 18i. Now, be careful when you have subtraction, because you can add the opposite of the second number, and that includes both of those numbers behind the subtraction sign. So both of those numbers in the parentheses. So I have 4 plus a -2i, which is 2. And I have 7i plus a -3i, which is 4i. I'm going to add the opposite of the second numbers here. So I have 9 plus a -12, which is a -3. And then I have a -6i and a -2i, which is a -8i. So that's addition and subtraction using your imaginary numbers. Now let's do a little multiplication using them. These are binomials. So we're going to use FOIL on them. So I'm going to multiply this times this, which is going to give me 12. I'm going to multiply this times this, which hopefully it will focus in on. Maybe not. There it goes. Okay, negative 20i. And this times this, which is a positive 6i. And last is going to give me 2i times a negative 5i, which is a negative 10i squared. So then I combine like terms. Understand this is negative 1. Negative 1 times negative 10 makes it positive 10. So I have a 22 because I have 12 plus 10. And then these, when I combine them, is going to give me a negative 14i. Over here, first is going to give me 16. Outside is going to give me negative 24i. Inside is going to give me positive 10i. And last is going to give me negative 15i squared. So when I combine like terms, I can combine these two. That I squared makes this plus 15. So I have a 31 minus a 14i, which is what I get when I combine those two. All right, your homework. I can get to your homework page. Is page 314 to 315, 20 through 58 even.